Okay. And let's see what else I want to do. I want to eventually tell you what we're going to be doing today. We're going to be talking about homework 2, and in preparation for that, I'm going to run through some concepts that you need to know, or homework 2 won't make any sense to you. And I'm going to do that first. I'm going to have to do a screen share in order to do that. So if you'll give me a moment to make sure that I can do that. And let's see. Okay, I'm going to do a screen share. All right. This I've got to get to work better than it is. Okay, I did it. We've got the screen share. You can all see a PowerPoint. Oh, I'm going to ask Dana. Dana, can you see it?
Yes.
Cool. All right. It worked. So we're going to be talking about descriptive statistics and how to summarize things graphically and numerically. So that being the case, let's move on. And if we've got categorical data, what we are going to do is draw bar graphs or pie charts. And categorical data, if you recall, is data that doesn't have units. It's just counting how many items are in each category. You can describe it as the number of items or the percent of items that are in each category. For example, I could make a pie chart of SSU, how many are freshmen, how many are sophomores, how many juniors, how many are seniors, just counting the number of people in each group. That's not what we're going to do today. In fact, some of the whole homework problems are about that, but I think that part is very well covered in chapter 2. What we're going to do today is talk about numerical data, data that has units, and graphs that we make to describe numerical data are histograms that I bet you've seen before, box whisker plots that you've probably not seen before, and stem leaf graphs that you probably haven't seen before. So let's get at it. When you're summarizing numerical data, you summarize it by numbers and by graphs. The numbers fall into two categories. You're either interested in where is the center? Where is most of the data? There are 3 ways that we measure the center. The most naive way of measuring the center is the data value that occurs most often. For example, I graded an exam, and most people, the value that occurred most often was 85. More people got 85 on their exam than any other value. That's not very reliable, because if I gave the exam again to a different group of people, 87 might have been the mode, or 92 might have been the mode. The mode varies a lot from sample to sample. It's convenient, but it's not reliable. The median, you organize the data values from smallest to largest. Then you pick the one that's in the middle. 50% of the students got less than this grade, 50% got more than this grade. So if I tell you the median is 85, you know that 50% of the students got more than 85 on the exam and 50% got less. It's the middle value. It's more reliable, definitely more reliable than the mode. The problem is you don't know anything about the students that are on the high end. Maybe 5 people got 100, and you'll never know that because all I'm telling you is the median. Maybe 2 or 3 people got a 42 or 43, and you'll never know that because I only gave you the middle value. The mean is the most reliable. It takes into account every single data value. It takes into account the 42, the 43, and the 5 people that got 100. Okay, you take all of your data, you add it up, and you divide by, say, 35, if there's 35 students. It's basically the average of all the data. It is the most reliable. It varies the least from sample to sample. It is also the most tedious to calculate it. You will definitely want a handheld calculator, or if there's a lot of data, you will want a piece of software that will do that for you. So we got 3 ways to tell people what's the center of the data. That's not the only thing that's important, though. We want to know, is the data very spread out, or is it pretty tightly clustered around the center? The range helps us to do that. It's the difference between the maximum and the minimum. Very unreliable. Maybe in this class, somebody got a 42, but in the last class, but the next class, maybe the smallest was only 52. It varies a lot. Better than that is something called the interquartile range. We'll have to talk about that in a moment. It measures the difference between the 75th and the 25th percentile. It focuses on the center of the data, but ignores the edges. The most reliable and the hardest to calculate by hand, essentially almost impossible to calculate by hand, is the standard deviation. It takes into account every single data value. So if we're going to talk about the interquartile range, I have to talk to you about a graph called a box whisker plot. Probably haven't heard about it before. It's very, very popular in statistics. What it does is it orders things from smallest to largest. And there's a marker for the minimum and a marker for the maximum. The next thing it does is it moves itself up to the 25th percentile. It finds the number so that 25% are below that number, and 75% are above that number. Then it moves on to finding the median, the one that's in the middle, 50% below, 50% above, and marches on to find the 75th percentile, 75 below, 25 above. Now, if you were doing this by hand, this is what you would do. You would order the data from smallest to largest. You would probably find the middle piece first. Then you take that middle piece and cut it in half, and that would be the quartile 1. You'd take the middle piece and cut it in half, The middle of the upper half is quartile 3. Long story short, what's a box whisker plot? It shows you the middle 50% of the data, bounded by these lines on the edge. The 25th percentile, Q1, the 75th percentile, Q3, and in the middle is the median, the 50th percentile. How do you make the box connected to the minimum and the maximum? By a whisker. You start at Q1 and you go out to the minimum, and that's the lower whisker. You start at Q3, you go up to the maximum, and that's the upper whisker. So there you have your box. If you say to yourself, I wonder how wide this box is. How wide the box is Q3 minus Q1. The width of the box is the interquartile range. It's how wide the box is. If the box is narrow, there's not much variability around the median. If the box is wide, there's a lot of variability around the median. The IQR measures the width of the middle part of the data. The IQR doesn't care about all of this stuff. It doesn't care about all of this stuff. It just cares about the middle of the box. Very important when it comes to homework. Any questions? So here's a picture, 25, 25, 25, 25. So what's happening, I'm going to move things around here. What's happening is, back up. Nope, back up. I want to go back. I want to go back, not forward. Back. Okay. So what's happening here is that Q1 and Q3 chop off the middle 50% of the box. Another picture, I've introduced something new in this picture, the concept of outliers. Sometimes we have data that have extremely small values or extremely large values, but it's not up to us as people who are non-statisticians to say, I think that's really small, or I think that's really large. We have to have a rule for that. Here's the rule. You calculate a fence, an invisible barrier. You take Q1 and you subtract 1.5 times the width of the box, and you come up with a number. That's an imaginary fence. If you're smaller than that imaginary fence, you're an outlier. On the other hand, on the upside, you take Q3 and you add 1.5 times the width of the box, and there's an imaginary upper fence. If you're bigger than that upper fence, you're an outlier. So we've got a rule that says it's not a wishy-washy thing. There are fences. Below this fence, above this fence, you're an outlier. Everybody okay with that? It'll come up in the homework. I'll send you the PowerPoint, but you might want to make a mental image or jot some things down right now. So let's see what else is happening here. Here it is. What is the IQR? It's the difference between the third and the first quartile. In layman's terms, it's the width of the box. In layman's terms, it measures the spread or the variability of the middle 50% of the data. It totally neglects the outside 50% of the data. It is not sensitive to outliers. It pretends there are no outliers. It doesn't care. Okay, I grabbed this out of a statistics book. Here is the formula for the standard deviation, just so that you'll know what it measures. You will never calculate it by hand. You take every single data value and see how far it is from the sample mean. You square those values so that positive and negative values won't cancel. Everything will be positive. Then you add all that junk up, divide by something like the sample size, and take the square root to get you back to the original units. What's the takeaway from this? The takeaway is the standard deviation looks at every single data value. It does not throw away the outliers. If there's an outlier in there, it will capture it. It'll put it in its formula and make it the standard deviation bigger. Outliers make the standard deviation bigger. It's giving the word, it's saying, there are some things out there that are a lot further away from the mean than you think they are. Any questions on that? So we'll have StatCrunch evaluate the standard deviation for us. Oops. So skipping ahead to graphs. There are two graphs besides the box whisker plot that are very popular. You might not have heard of this one. This is a stem leaf graph. So I have data that has 2 digits, games, points earned in games during a basketball season. I want to put this into a graph. I could make a box whisker plot out of that. But when I look at a box with a whisker plot, I only see some summary stats, the median, the quartiles, the whiskers. There's a lot of stuff I don't see. If I want to see all of the data values, what I will do is I will capture the tens digit, and those tens digits will be the stem. So there's a stem of a 1, a 2, a 3, a 4, and a 5. So I've ordered my data from smallest to largest. I think the smallest data value was 12 points. What I do is I put the 1 on the stem and the 2 on the leaf. Tens on the stem, units on the leaf. This would be read 20. This would be read 33. This would be read 51. Somebody out there, how would I read this number here? How would I read this number with a 4 and a 2?
42.
42, perfect. What's good about the stem leaf graph is you can read every data value from the graph. You don't lose any information. What is bad about it is if you have 1,000 units, can you make a stem leaf graph? No, it would go off the paper. It's good for small data sets. It's not practical for large data sets. So here's an alternative. I bet you've seen this before. It's a histogram, daily high temperatures. So what we've done basically is we've made a numerical variable into kind of sort of a categorical variable. We created some categories, some bins, some classes. We've counted how many days are between 10 and 20, between 20 and 30. And so we've made little categories. And then we've counted how many days in each category. And we've made something that looks like a bar chart, but it's a histogram, because this is 10 up to but not including 20. And then we skipped from 20 up to not including 30, and so forth. So these upper boundaries are in the second bin, not the first. So the difference between a histogram and a bar chart is the bars are all separated, the little discrete bars. A histogram is a nice, smooth graph that doesn't have no gaps. It's a nice, smooth graph. Okay, one last concept, and we're going to go on to the homework. Okay, here's a reminder of outliers. Oops, let's go back. These are regular outliers. 1.5 IQRs from the boundary. Sometimes you have outliers that are really, really, really extreme. They are so extreme that you're going to have a big fat asterisk, not a little dot, but a big fat asterisk to indicate they are extreme. They are 3 IQRs from the boundary values. So I'll send you this PowerPoint because there's a lot to digest, but those are the rules for finding low outliers and high outliers. Outliers do damage to the mean. They increase the mean. Low outliers make the mean smaller. The median doesn't care. The median doesn't care about the outliers. It only looks at the middle 50%. Outliers always increase the standard deviation. The standard deviation says way up, wait a minute, there's an outlier that's really far away from the mean. The standard deviation gets bigger. It doesn't affect the IQR. So here's the takeaway. If there are outliers, the mean and median are better than the mean and standard deviation. Okay, last concept. We'll start with the bottom graph. I bet if I said this was symmetrical, you would know what that means. Can anybody remember from maybe art or some other course what it means to be symmetrical? Just in your own words.
It goes like from like the start of the graph to like the end, like it's round basically.
It's round. It's rounded. Rounded is good. If you were to connect the dots here, it would be a rounded graph. And what about the left side and the right side of this rounded graph? Would they be the same or different?
The same.
The same. Okay. In other words, if you were to put, if this was a piece of paper and you put a line down the middle here and you were to fold it, the left-hand side would plop right on top of the right-hand side. The left side looks like the right-hand side. It's symmetrical. So that's what it is in statistics. Data sets that are symmetrical would have a graph that looks like this. Data sets that are not symmetrical would have a graph possibly looking like this, where that if you were to put a line down here right through the mode and fold, would the left side plop on top of the right? No. The right side would have what? More stuff. It would have more bars, so to speak, more bends. We call this skewed, and we call it skewed to the right. The right-hand side has more data. Or we'll call it skewed to the positive side. When it's skewed to the positive side, the median would be somewhere in here. And the mean would be somewhere over here. So the takeaway from this is when it is skewed to the right, the mean is bigger than the median. The mean is influenced by all of these large values. Conversely, if it's lopsided like this, it is skewed. But now your bins are on the left-hand side. This is skewed to the left. And the median would be about here, and the mean would be over here, because the mean is influenced, it's dragged down by all of these small values. So when it is skewed to the left, skewed to the low end, the mean is less than the median. Symmetry, the mean and the median are the same. Questions on that? It's really counterintuitive. Sometimes people think that because the peak is on the left, they'll think this is skewed to the left. It's not where the peak is. It's where the majority of the data is. Skewed to the right, majority of the data. Skewed to the left, the majority of the data. Symmetry, no difference. On a box plot, symmetry. Positive skew, most of the data is over here on the right. Negative skew, most of the data is over here on the left. So you can see skewness on histograms, you can see it on box plots. So if your distribution is skewed, there's going to be a problem. The mean and the standard deviation aren't going to be representative of the data. They're going to be inflated or deflated. So you're going to prefer the median and the IQR when you have skewed distributions. If it's symmetrical, go with the mean and the standard deviation. Homework problems. Okay, you're going to take a break. I'm going to try to pull up your homework and get a new screen going. So take a mental break here. Got to rearrange things here. Okay, so I've got to get out of this. Got to get out of that. And I've got to get into the homework. I'm working on it, guys. Okay, now I have to do some magic. I have to make sure you can see this screen. And the magic didn't work. Oh no. Oh, that should, okay, now the magic worked. Okay. No, the magic didn't work. Oh, share screen. Okay. So here we are. We are in homework. I happen to have accessed the homework through the modules. It was module 3. And I hit homework 2, and here is homework 2. So we are going to look at problems. What were the problems I said we were going to look at? 14. I played around with 14 and then I aborted it, so we'll have to look at it again. Okay, so I'm going to check that answer on that one. And it's incorrect, just as well. Okay, so we have to redo the problem. So see the slider bar here? In order to open this in StatCrunch, which I definitely want to do, I'm going to have to use this slider bar to get over here and click on this. What we've got is we've got the, what have we got here? Number of deaths by flood in a certain country. We're going to open it in StatCrunch. And it should still be within the window. I'm assuming you can see this. Can you see StatCrunch?
No.
No. Oh, rats. Okay, so where is StatCrunch? Hmm. Now you can see it, right?
Yep.
Okay. Oh, shoot. Where did it go? A lot of moving stuff around here. I moved it around too far. Okay, there it is. Okay, so as far as the number of deaths by flooding, we've got 21 observations. I'm scanning this data. There's one that looks to be pretty big here, but I'm not going to do anything by hand. Okay, I'm going to do it all by getting StatCrunch to do it for me. Now, I could go under stats, summary stats on the columns, and I could get all of the summary stats. Or there's an alternative. I could go under graphs. I could go under graphs and pick box plot, simply because we really haven't done a box plot before. Variable 1, I would like to see both the mean and the median. Now, ordinarily, the mean is not part of the box plot, but it is in StatCrunch. We're going to draw the boxes horizontally because that's the way I like them. And we're going to compute it. Okay. So look, what is this box plot telling us? Are there any outliers? No, because I said, show me the outliers. Are there any outliers? That 178 apparently is not an outlier. What about the mean and the median? Well, if you hover over this red bar, that, oh shoot, they're so far, they're so close together, you can hardly tell the difference. You can see the box plot, can't you?
Yep.
Okay.
Yeah.
They are so close together that they appear to be the same. The mean is 81.71, and the median is 81 point, oh, I can't even get it. The median is 81. And if I hover over the box itself, I can get the IQR, the median, and Q3 and Q1, and the upper and lower limits. So that's cool. I'm going to get out of this for just a minute. And since there were no outliers, I thought there might be. Let's do it this way. Stat, summary stat on the columns. Pick variable 1. You can still see it, right? Maggie, yes?
Yes.
Okay. So I'm going to click mean. I'm going to, on my Apple, depress the command button. Standard deviation, we did study, oops, I put that there by mistake. Median, range, min and max, all of these things that we've studied. IQR, and that is it. I don't care about the mode. Let's compute it. So when you're doing a problem like this and you don't know what the question is going to ask, my feeling is click on everything that you have studied in the class and jot it down. For example, the mean, when there's something that has decimal places, they usually want 2 decimal places. So the mean is going to be 81.71. And the median is going to be 81. And Q1 is going to be 51. And Q3 is going to be 103. And the IQR is going to be 52. So we can kind of X out of that. Oh, shoot, where's my problem? Oh no, share screen. Oh no. Can you see the screen?
Yep.
Okay. Okay, so 81.71, and the median was not 20. The median was 81. And I'm going to check my answer. If I can move this up or move this around. Check my answer. And it says nice work. Now it's going to be boring to you for me to enter all the other stuff. It's going to ask for Q1, which we all wrote down, and Q3 and IQR, and the rest is kind of boring. But the takeaway from this is use this sliding bar to open it in StatCrunch. Let's go to the next problem, which I think is something I wanted to do with you. You've not completely, do you want to go to the next question? Yes. I'm going to close that. Next question, tornadoes over 21 years. And then we're recording the number of deaths. Okay, so let's see. This is not an ABCD. They only want to know whether the deaths have an extreme outlier. They want to know about the median and the IQR. So if they want to know about an extreme outlier, what kind of graph should we create? It's the one graph that showed us the outliers. How about Mark? Mark, what graph shows us the outliers? Open this in StatCrunch. So our choices of graphs are stem leaf graph, box plot, or histogram. Which one should we pick?
Can you say them one more time, please?
Sure. Stem leaf graph, box plot, or histogram. Which one shows the outliers? Anybody just want to jump in there, and I'm under my graph menu. Pick one. What should I pick?
Box plot.
Thank you. Box plot. Let's just see what happens. Box
Professor, we can't see where you are right now. We just
Oh,
have
you
a
can.
question.
All right. So you can see this. Can you
We can see the question homework too, but
okay.
I guess you have to do it every time you go to
Yeah.
yeah.
So new share. Now you can. I should be looking for that green box, shouldn't I? All right. There's your data. Graph. Which one should I pick? Box plot. Yep, you can still see it, right?
Yep.
Cool. Use the fences, because I want to see about the outlier. Draw them horizontally. Show me the mean and the median. Median is automatic, the mean is not. Compute. What a silly box plot. That's weird. Number of deaths by tornadoes. I would like, I've got to searching here. Alexander, tell me one thing that's unusual about this box plot.
It's too small, I guess.
The box is very small. I agree. The box is very narrow. So the IQR is going to be very small. Okay, the box is small. That's good. There's something else that's unusual. Jessica, what do you think?
I was gonna say,
Maybe. Oh, sorry. That was saying Jess.
Say that again. Person who was speaking up is anybody else? Open it up to you.
Yeah, I was saying that maybe it's the 553 as an outlier.
Outliers. You said the magic word. Outliers. There's outliers. There's dots. Now, StatCrunch doesn't distinguish between low outliers and high outliers. It's not going to put dots and asterisks. It's just going to put dots for outliers. So there's at least 2 outliers. And you know, this thing here is a little fuzzy. This looks like it might actually, have 2 points. So here's some magic. If I want to know what this outlier is, I'm going to click on the left-hand corner and drag and put a little box around it. And there it is, 553. And I'm going to write that down in case it asks the question. There seems to be a high outlier at 553. In that particular year, there were 553 deaths by tornado. That's unusual. I wrote it down. I want to clear that and investigate these 2 guys. I think there's 2 dots there. There are. There was a year when there were 130 deaths and a year when there was 126. And that, by all accounts, is unusual. It is unusual in what respect? See this upper fence here, this Q3? It's way far away from Q3. It's 1.5 interquartile ranges away. This one is 3 interquartile ranges away. So we've got 3 outliers. Now, while we're here, we can hover over the box, or we can hover over this red line. Oh, it's hard to hover. And jot down that the median is 54. That's the red line. And we can pick up the green line. Hover, hover. The mean is 81.4128. 81.4.
Doesn't the mean become 81.43?
It does, 0.43. Perfect. Who helped me with that? Who's my helper? Oh, come
Me.
on. Don't
Mark,
say me because there's 34 me's.
Mark,
Huh?
Mark.
Mark. Thank you, Mark. And my screen only shows about 5 or 6 of you at a time. Okay, so let's just anticipate what might be asked by the problem. So I can hover and I can get IQR is 32, Q1 is 38, 38, 70, 38, 54, 70. With an IQR of 32. And I think I've jotted all I need to jot down. I'm going to X out of this and do another screen share. Oh, take a deep breath here. And do another screen share. Okay, and we're back to the problem, right?
Yep.
Okay, so the distribution is skewed. So remember how it was the box was really tight, and then there were those high outliers. If there's high outliers, in which direction is it skewed? I made it horizontal so the big numbers would be on the right and the small numbers would be on the left. So where were the big numbers? It is skewed to the where were the big numbers? On the right. It was skewed to the right. There was an extreme outlier at 553. The median was, if I got it right, 54, and the IQR, if I got it right, was 32. And so let's just check our answer and see if we got that right. And I'm going to have to move this. Dun-dun. Check our answer. And we did it right. Okay. So are we okay with that?
Yes.
Think about it. When you think about it, oh, that was 16. When you think about it, if the high outliers are on the right, then it is skewed to the right. If the outliers are on the left, if there's small outliers, then it is skewed to the left. Okay. And did you notice the IQR was only 32? It was a very narrow box. Okay, pieces of pizza for 314 weeks in a large city. What would you use to summarize the data and why? Well, if there's 314 weeks, we certainly don't want a stem leaf graph. There'd be too many leaves. we could do a box plot, but they chose to do a histogram. Does this look like symmetrical, skewed right, skewed left? And we're going to use the word approximate here. I mean, so is it approximately symmetrical? Is it profoundly skewed right or profoundly skewed left? What is it?
Symmetrical.
I'd say symmetrical. It's symmetrical. Now, if it's symmetrical, what statistics will we use? Will we use the mean or the median for symmetry?
The mean.
The mean. Okay, the mean is the better of the two statistics because it takes all the data into account. The only reason we go with the median is it because of skewness, and then the mean would be deceiving. So we are going to pick the mean, not the mean and the standard deviation because it is symmetrical. For symmetry, we like the mean and the standard deviation. We're going to check our answer and hope we're right. Cool. So I have to move things here so I can see. Okay. All right. So in this problem, we're recording temperatures for weekly low temperatures that were observed in a southern home last year. The coldest temperature was really 36 degrees Fahrenheit, but the person recording it made a mistake and he recorded it as 32 degrees. Assuming that all the other temperatures that he recorded were correct, what will be the impact of this mistake on the mean, the median, the IQR, the range, and the standard deviation? So long story short, he blew it. Instead of recording 36, he recorded 2. He made a mistake. So what is it going to do to the mean? Is the fact that he recorded the wrong thing, and the wrong thing was less than it was supposed to be. What's it going to do to the mean? Is it going to not be affected, be lower, or be higher?
Be lower.
Be lower. The value was lower than it expected, so it will affect the mean. But he did it for, I guess, I don't know, for a whole year, 365 days. So there's only one bad measurement in 365 days. What about the median? The median is the middle 50%. Is one low observation, one extremely low observation going to affect the median?
No.
No, it won't be affected. Median just cuts the data in half. It doesn't care what's happening to the left or to the right of it. It doesn't care. Okay, so we are going to, I'm going to move this. We're going to check our answer. Okay, so far so good. Okay, I'm going to move this again. Okay. What about the range? The range is the difference between the largest and the smallest. Here's our choices. It'll be higher, lower, or not affected.
Higher.
Really? It will be. It will be higher because it's the difference between the smallest and the largest. Okay, so it will be higher. What about the IQR, which doesn't care about what's happening on the edges? It just works, it just looks at the middle. The IQR going to matter?
No.
No. What about the standard deviation? The standard deviation cares. It takes into account every single observation and measures how far they are from the mean. And this value is pretty far from the mean. So what's going to happen to the standard deviation? It will be affected. It would have been, it's going to be higher. It's going to be higher because it replaced the 36 by something that was further from the mean. Okay, so it's going to make it higher. And I think we're out of the woods here. We're going to check our answer and be done with it. Okay. We're done with it. So we're going to move on to the next question. And forget about the instructor's tip. Okay, here we have a stem leaf graph. And it's not the way I displayed it. It's going from highest to lowest. It's talking about the population in 51 regions, probably the 50 states, in millions of people. Then we have to complete parts A and B, and part B is a secret, so we don't know what part B is going to be. So I feel more comfortable looking at box plots. Anybody want to describe why I might be more happy with a box plot instead of a stem leaf graph? And it has to do with this observation of 31 million. It could be a what? It could be an fill in the blank, the word begins with an O. What could that 31 be?
Outlier.
It could be an outlier. Can I be definitively sure of it being an outlier from a stem leaf graph? No. Okay, I would have to do some math for it, but it wouldn't show up as a big dot on my graph. So I'm going to open this in StatCrunch. And I'm sure I'm going to have to do a new screen share. Okay, where is a new share? Now you can see it, right?
Yep.
So we're going to go graph and we're going to pick box plot. And we're going to do them horizontally, show the fences and the mean and the median. We're going to compute. Okay. So was that an outlier? Do we have a definitive outlier here? Yes. There it is. It's lurking over there. Who is this guy? 31, just what I thought. So there is a high outlier at 31. Can you tell me what the mean is? Well, possibly. If I hover over the red, that's the median. The median is 5. And if I hover over the green, the mean is 6.67. Which one's bigger? The mean or the median? The mean. The mean is bigger than the median. And we got this high outlier. This distribution is skewed. Help me. Okay? Help me, somebody. It is skewed to the what direction, right or left? We have a high outlier. The mean is bigger than the median. Who
Left.
added? It's skewed to the, where's the high outlier? It's on what side?
Right.
The right. It's on the right side of the box. It's skewed to the right. It is skewed to the right. Okay, and so that we don't have to go back and jot any more stuff down, let's just, oh, hover, hover, hover. Let's just, the IQR is 6. The Q3 is 3. And the median is 5. Oh, the Q3 and no. The Q1 is 3 and then 5 and then 9. Okay. So let's X out of this and go back to the homework. Okay. So I can fill this in now. The mean is 5, whoops, 5, and the IQR is 6. And we can check our answer. And we did it good. And here's the next question. Write a few sentences. The distribution of these regions is it got a mode, no mode, or bimodal? Look at the stem leaf graph. Does it have a mode?
Bimodal.
What are the two modes? Maybe, well, I'm switching between unimodal and bimodal. I'm thinking unimodal because of this. I don't see the bimodal. Not sure how I could argue for the bimodal. Can we try unimodal and see if it works? And then it's definitely skewed to the right and there's only one outlier. Let's see if my hunch that it's unimodal is correct. Okay, it agreed that it was unimodal. So the reason I said unimodal, oh shoot, move this stupid thing. Can't move it. The reason I said unimodal is this looked like the one and only mode. Okay, in the interest of time, let's go on to number 19. "20 seasons of hockey. Certain hockey player scored 50% more points than anyone else. He accomplished this feat while playing in 280 fewer games than the previous record holder. The number of games he played, blah, blah, blah. God, that's a lot to work with. Would the mean or median be able to?" All right, let's look at the data. Okay. So what are we studying here? And I've got to do a new share, right? Is that true? Can you still see this data? Can you see the stem leaf graph?
Yeah.
Okay, cool. So does it look symmetrical? Would you rather see it as a box plot? You can. Let's see. Yes, we can see it as a box plot if we want. We can open it and stack punch. Do I need to do a new share now?
Yes.
Okay. Okay, there it is. So let's see what it looks like as a box plot. Fences, blah. There it is. Okay, we have something different here. We have two outliers, and guess what? They're on the other side of the box. Mean and median are not the same. Okay, so in anticipation of some questions, let's see who these outliers are. They are 46 and 47. Good to know. Okay, let's look at the mean. The mean is 74.5. And the median is smaller than that. The median is 79. I'm sorry, it's bigger. Sorry, 79. So why is the mean smaller? It's influenced by these small values. These small values are dragging the mean down. This graph is not symmetrical. Please tell me, it is skewed in what direction, left or right?
Left.
Left. The outliers are on the left-hand side of the box. The mean is smaller than the median, dragged down by those small values. I don't know what they're going to ask us other than that. Maybe they want the IQR, which is 7.5. Let's pretend that's all they want and get out of this and get back to the problem. Oh no. Screen share. You can see it, right?
Yep.
So what should we use to summarize this? Here's our choices, the mean or the median. The mean is great if there's no skewness. The mean is great because it takes into account all of the values. But if there is skewness, if there is outliers, the mean is deceiving. When it takes into account those very low values, you think the number of games played is smaller than it really is. So you won't use the mean because it's inflated, it's deceptive, it's influenced by those small values. Skewness, prefer the median. What should be center of the, because it is skewed. Oh gosh, we gotta get this out of here. It is skewed. Check the answer. The median was 79. Check the answer. And without actually finding the mean, what do you think would be, what does it say? Without actually finding the mean, would you expect it to be lower or higher than the median? Lower. Sorry, the graph is gone. Just picture that one dot not being there. It's either about the same or higher. I think it would probably, you take it out of there. You take it out of there and there's no reason it should be lower. Probably about the same. It'd be fun if we could take it out of there and actually find out. I think if you take it out of there, things would be about the same and it would be symmetric. Oh no. What is it? What does our little message say here? Get my message down. Histogram is symmetric if there are no outliers. Oh, rats. Well, we've only got a couple minutes left. Let's open it in StatCrunch. What was the outlier? There were two outliers. They were what? 46 and 47. Where's the 46? Okay. Edit. Forget how to delete, edit. Rows, delete. All right, we've deleted them. Now let's look at the graph. All right, then we're gonna go. Okay, they were right. It's still skewed. If you take the outliers out, the mean is still smaller than the median. Okay. So two things are happening that making me think this is the end of our session. The dog has started barking. And I made a mistake on the last one, but then I checked my mistake by actually going in there and deleting the outliers and seeing that the authors are correct. It is still skewed, and it's skewed towards the low end, even after deleting those two outliers. Okay, so I'm going to stick around. The dog has stopped barking. I'm going to stick around for a few minutes if you have other questions to ask. Okay. If not, I'm here for you during the week. You can always send me an email. Let me do something quickly here. Oh, let's see. Get out of this. At the very, very bottom here, I hate these scrolly things. There's a help me solve this. I can't even find it with this. Get more help, okay? Get more help. You can view an example, help me solve this. Look at those, they're really good. They guide you through the problem. Whenever you're stuck, remember they're there. They sometimes even do the problem for you. And then the last ditch effort after you've tried everything and you're still confused, ask my instructor, and boom, that sends me an email with your name and the problem that you are working on. All right. So you guys have a good week. I will see you next week. All right.
Thank
Here.
you.
Bye.
Thank you.
Thank you.
Thank you.
Bye.
Bye, thank you.
Bye-bye.
I just had a quick question.
Sure.
So I was wondering, are the exams like the same format as the homework? Like
They
have-
are the same format. I have a review for exam 1
Mhm.
that will show you exactly what the format is. Some of them are fill in the blank, some of them are drop down menus. You will know what the format is when you take the review for exam 1, and you'll know what the material that I'll be focusing on. The big difference is there's a time limit. It's 2 hours.
Is it like
I-
20 questions still, or like a little
I
more?
think there are 20 questions. The same number of questions as in the review, whatever the review has. There is a time limit, and once you start it, the clock starts ticking. So, you can't answer a phone call or you can't answer a text. I mean, you've just got to be totally focused for that 2 hours, because you can't go away and come back again. That's the big difference.
That was my only question. Thank you.
Okay,
Nice day.
bye. Have you too. How you doing, Vanessa?
Good, Professor. Sorry.
Hi.